Learning target 9.6 says I can distinguish between acids and bases based on their properties, and you can read through this when you're doing your study guide for chapter 19 as well. So if you think about common things that we know are acids and bases, you can relate some of these things to them. Like acids have a sour taste, like orange juice, any kind of citrusy, lemon juice, those kinds of things. They sting when they come into contact, like, if you've got a little paper cut and you spill juice on your fingers, you know how it feels. It stings. Acids are going to react with metals. They're going to turn blue litmus paper red. This is a common experiment that you do in middle school. Now, here is what's going to make an acid for us. They're going to contain more hydrogen ions than hydroxide ions, okay? And we know that pH for acids is between 0 and 7. Now, bases are going to taste bitter. If you've ever gotten soap in your mouth in the shower, it has a bitter taste to it. They're slippery. Again, think about the way soap feels. They don't tend to react with metals. They're going to turn red litmus paper blue. Now, they're going to have more hydroxide ions than they do hydrogen ions. And pH is going to be 7 to 14. Now, all solutions, or all acids and bases, are going to contain both hydrogen ions and hydroxide ions. But what distinguishes the two is the concentration. If there's more hydrogen, you have an acid. If there's more hydroxide, you have a base. Now, there's some theories that are popular. This is the one we're going to look at for our class, the Arrhenius model. Basically, if you have hydrogen first, you have an acid. If you have hydroxide, you have a base. That's what Arrhenius means. Now, Bronsted-Lowry, we get into conjugate acids and conjugate bases. They're proton donors and proton acceptors. So we consider an H plus to be a proton. Now, Lewis gets really, really deep into things, and we don't really have to go there. But it talks about electron pairs as opposed to protons. So a conjugate acid base, this is when we're dealing with Bronsted-Lowry. A conjugate acid is going to form when a base gains a proton. So for example, when you have hydroxide and you add a hydrogen to it, you get water. So water is a conjugate acid of hydroxide. Okay, so a conjugate base is going to form when an acid loses a proton. So if we start with an acid like HCl, it ionizes when we put it into water. Chlorine is what's left when we take away that hydrogen. So the conjugate base of HCl would be chlorine.